All right, my algebra wizards, welcome back. It's the crazy lady. If I'm not your teacher, it is Mrs. Robinson. So, welcome for more fun. This is Unit 7. This is a big unit, people. So, we got to step up our game. So, systems of equations. So, we have been in the world of y equals mx plus b and rise and run in one line. Now what are we going to do? We're going to introduce another line and make some magic. So that is called a system of equations. So the solution to a system of equations is an ordered pair. Okay, where does it cross? So that's what we are going to, that is what we will be doing this unit. Where do they intersect? That is a solution for both equations in the system. So where do they both cross? All right. So how I do this. So this is a map of Disneyland. Okay. So let's say, for example, so if you haven't been here, it is a magical place. So try it out if you can ever do that. So let's say that I am at Space Mountain and I am going to go to the Matterhorn. Okay. And then my family is at, let's say that they are at Walt Disney. They're hanging out with Walt Disney and Mickey. And they are going to go to Cars Land. So they're going to go ride Autopia. So they're going to ride the cars. So where would we meet? Would be right here. Okay, that's where we would intersect if we were both matching up. Okay, so some real life situations. Let's say that you are in N Hall and your friend is in O Hall. Where do you intersect to meet up for lunch? Of course. Okay? So that's what we're doing. So determine if the point is a solution to the system of equations. So what that means is it has to work for both equations. So I have negative 7x plus y equals negative 13. And then I have x minus 5y equals negative 3. All right. So what are we doing? Plug it in, plug it in. We're plugging in this x and y into the equation. So I have negative 7, and I'm going to times it by 2. And then plus, what is my y? 1. And then I'm going to make it equal to negative 13. And let's see if the two sides work. So negative 7 times 2 is negative 14 plus 1. And does it equal negative 13? Well, negative 14 and a positive 1, they're a positive and a negative. I'm going to subtract. And who won the tug of war? The negative 13. So does negative 13 equal negative 13? Yes. That's like saying, do you have first period algebra? That would be a solution. First period is the input. What is the output? Algebra. And then you plug it in. All right, let's try it for the next one. So what is my x? My x is 2. My y is 1. So I'm plugging in the x and the y, and I'm seeing if the two sides equal. So I have 2. I'm going to bring that down. Okay. Then I have minus, well, what's negative 5 times 1 is negative 5. And we're going to see, question mark, if it equals negative 3. Well, by golly, it does. 2 minus 5 is negative 3 equals negative 3. Yes! So yes, this is a solution. So what does that mean? That means that this line and this line will cross at this point. Okay, so you have to plug it into both of them. All right, let's try A. Again, this is my x, this is my y. I'm plugging it in to see if the two sides equal. So 2x minus y equals 11. And then I have x minus 3y equals negative 5. Plug in the x and y and check back. All right, I plugged in the x and the y to each of them, and now I'm going to solve. So it's really important you guys are trying these out at home. Don't just write down the answer. Do the work. You got to get it done. So 8 minus a negative 3, well, I think that's a positive. Yes. 8 plus 3, 8, 9, 10, 11. Hoo-doo-hoo. Awesome. 11 equals 11. Awesome. All right, now let's try this next one. 4 And then what's negative 3 times the negative 3? Well, that is a 9. That is a positive 9. Woo-ba-doo-woo. What's going on? So 4 plus 9 is 13. Now, does that equal negative 5? That would be no. So this is not a solution. So that would be like if you had for first period algebra and your friend had first period science. You do not intersect. You do not have the same class at the same time. So it worked for this one, but it did not work for this one. So it is not a solution. Plug in the X and plug in the Y. All right. Now, okay, so that is our mission. So for number 2 and number 3, we are plugging it in. So we are graphing these and seeing where they cross. Okay? And then we're going to plug in that point and check. So let's graph this first one. Now my y-intercept is 3. 1, 2, 3. And my slope is 2. Up 2 and left 1, or down 2 and right 1. Woohoo! It's not negative. Sorry, folks. Hello, what am I doing? All right, up 2 and right 1. Hello, there it is. And down 2 and left 1. So is this my positive slope? Woo! And what's really important with systems of equations, guys, is you want to graph a lot of points. So if you did that zombie graph, you needed it to fill up the entire graph to see where it crossed. Same thing here. So I went up 2, right 1, or down 2 and left 1. That makes a positive slope. So that's my first graph. Highly recommend using some colored pencils or highlighter or something so then you could see your two graphs. So my green one is going to go down 2. That's my starting point. And here's my negative slope. I go up 3, 1, 2, 3, and left 1. If you were taught to go down 3, 1, 2, 3, and right 1, it'll be the same graph. But let's see, folks. They intersect. That means they cross. So think of two streets, what the intersection is. All right, what is that point? Okay, that's what I want. That's my solution. So my solution is negative 1, 1. Now I'm going to plug it into the equation. I'm going to plug it into both of these and see if I'm correct. It's like having insurance. You hopefully don't need it, but you're really glad when you do. Okay, so I'm plugging in my X and my Y. And I'm checking to see if I did it right. Okay, so 1 equals 2 times negative 1 is negative 2 plus 3. Well, negative 2 plus 3 is 1. 1 equals 1. Awesome. It worked for the first one. Again, that point has to work for both of them in order for me to be a rock star and have the right answer. So Y is 1. I'm going to plug that in for this one. Equals negative 3 times what was my X? Negative 1 minus 2. So what am I doing? I am plugging in this point into both equations. Okay? All right, so 1 equals negative 3 times negative 1 is positive 3 minus 2. 1 equals 1. Hallelujah. We got it done. All right. That is awesome. So we got the answer. Yes, yes. And we got the intersection. Perfect. All right, number 3 is a little bit trickier because we don't have Y by itself. So we got to do that first. All right, so first we got to isolate that Y. So what do I do with this 4X? I subtract it to both sides, move the whole thing. Then I have 2Y equals negative 4X. Opposite of multiplying, dividing. So my equation is Y equals negative 2X. All right, so that's my first equation. I'm going to start at the origin because my y-intercept is 0. I'm going to go up 2 and left 1, up 2 and left 1. If you go down and right. So down 2 and over 1. Make sure you are going over 1. Okay, you don't want an undefined slope. All right, so that's my first graph. Now I'm going to bring this other one over. Now, how do I get this Y by itself? First, I should add 6 to both sides. So I have 3Y equals negative 3X plus 6. Again, how do I isolate that Y? By dividing 3 to everything. And I have Y equals negative X plus 2. All right, let's graph this. The y-intercept is positive 2. And then I'm going to go up 1, over 1. Up 1 over 1. Up 1 over 1. Well, looky here. They intersected right there. What is that point? That is my solution. That is the mission, folks. So over 2 and up 1, 2, 3, 4. So -2 up 4 is my solution. That is what we are trying to find this entire unit. So for day 1, we are graphing. So now let's check. What I like to do is I go back to my original equation that I was given, and then I can make sure that I did everything right. Okay, so what if I didn't solve it correctly for y, or what if I didn't graph it correctly? Again, checking is your insurance. So plugging in for x, -2. For y, 4. So always feel free. So you want to plug in the x and the y, and then check to see if you got the right answer. So plugging in the x and y into the original equation and checking your work, checking to see if you get the right answer. So plug those in. So the first one, -8 plus 8 equals 0. 0 equals 0, looks good. Now let's try the next one. 3 times 4 is 12. 12 minus 6 is 6. Yes! We want both sides to equal, and then now I know that my solution is -2, 4. Solving for y, graphing the two lines, finding where they cross, and then checking. So this is a lot of work for just one problem. And now there's more. Haha, there's more. All right, so for number 4, we want to get y by itself for both and graph. So try those out and check back. All right, so both of the equations, I got y by itself, and now I'm going to graph them and see what happens. All right. So the first one, I start at 2. I go up 2, rise 2, and run 3. It's a negative, so I'm going to run to the left. And then if you go the opposite, so if you like to go down when you have a negative slope, you'll go down 2, and then to the right 3. And therefore you have the same line. So y equals -2/3 x plus 2, so that's green on my graph. And if you notice, my second one, when you subtract the 2/3 x to the other side, you have the same graph. So that means, so what if you had all the same classes with another student? So that would mean you would have infinitely many solutions. So you guys have solved equations like that, where both sides equal each other, okay? So when you get something like 0 equals 0, that means that it's infinitely many solutions because you can plug anything in. All right, so if you made these two equal to each other, you would notice the x's go away and 2 equals 2, and then that means infinitely many solutions. So checking, you can plug any point in. Okay, you could plug in something for x and you'll get the output of y. All of these points on these lines are the solutions. All right, let's try B. All right, so y equals x plus 3. I start at the 3. I go up 1 over 1 to the right because it's a positive slope. And then my second graph, let's make a different color. So let's make that blue. So y equals, Reno High. All right, y equals -3x minus 5. So I'm going to start at the -5 on the y-axis. 1, 2, 3, 4, 5. I'm going to go up 3, 1, 2, 3, and left 1, 1, 2, 3, left 1. I can't really go down and over because then I'd end up over here. So you want to make sure that you make the lines long enough to see where they intersect, okay, if they intersect. All right, this one is -2. -2, 1 is my intersection, and now let's plug it in and see if we did it right. All right, so I write down both equations. I plug in the x and the y. Plug in the x and the y for both, and then I will solve and see if they work. So 1 equals, so negative 2 plus 3 is 1. 1 equals 1. Holla, it is done. Let's try the second one. Negative 3 times negative 2 is a positive 6. 6 minus 5 is 1. So 1 equals 1. We did it right. Okay, so as long as the two sides equal each other, we are good to go. All right, so we just keep on going. So C, we need to get y by itself. So moving that x over and dividing, so then we can isolate that y, graph it, see where they intersect, and then check. So rinse and repeat, that's what we're doing. So let's try C. I want you to isolate that y and then graph the two equations. All right, my first equation is orange, starting at the negative 2, rising 4, and running to the right 1. So that's my orange graph. So you remember, isolate that y, subtracting the 4x, and then dividing by negative 1. My purple graph, I had to subtract 2x to both sides, and then start at the 4. I couldn't really rise and run to the left, so I went down 2 and to the right, make that negative slope, and I found the intersection. So it's like your friend and you don't have the same first and second period, but then you have the third period the same. All right, so finding out what you had in common with someone else, it's like when you have two graphs and where do they intersect? Or think of streets, what that intersection is. All right, now plug in the x and the y and check your work. All right, plugging in the x and the y to both equations. I went to the original equations, okay? And now I'm checking to see if I got the right answer, okay? Algebra is pretty hardcore. You got to keep working on it. So check to make sure that you got these right and finish these up. So 4 minus 2. 2 equals 2. Awesome. And then on this side, 2 times 1 is 2. 2 plus 2 is 4. And 4 equals 4. So isolating y, graphing both lines, finding what the solution is by where they intersect. Where do they cross? And then checking. All right, let's try out the D. The first one is ready to go. The second one, we need to move over, and then we can graph both of them. All right, so let's graph the first one, y equals 2x minus 4. We start at the negative 4, and then rise 2 and run 1. So this one I'm going to have be the red. All right, now the second one, starting at the 3 on the y-axis and then rising 2 and running 1. This is interesting. So, if you notice, something is similar. They both have the same slope. Their slopes, or their m's, are both 2. So when that happens, that means that there's no solution. That's like you and your friend are both freshmen, but you have no classes in common. So that means what is similar, that you're both freshmen, but there is no solution because not having any classes together. Wah, wah. Or one of you being A day and one of you being B day. Okay? So you wouldn't actually have a class together. So it's no solution. Can we check it? No, because there's nothing to plug in. So if you get the same slope and different y-intercepts, you will get no solution. So make a note of that. All right, now we're moving along. Woohoo, a multiple choice question. Let's do this. The graph and the table of values are given to represent two linear equations. Which of the following is the solution? Well, by golly, we already have a graph. Let's graph those points and see where they intersect. So I graphed those 3 points, and I noticed that they cross right here. Now, what is that? I think that's 2, 0. The answer is A. So when you have something like this, plot those points and see where they intersect if you have something like this. All right, number 6. The equations of the 4 lines are below. Which two equations form no solution? Well, if you remember, a system that has no solution means they have the same slope or the same m. So that means I need to isolate the y for every situation and then see which one has the same slope. What is that m for them, okay? Well, if you notice, line 2, line 3, and line 4, we can already figure out what the slope is. But line 1, I'd have to solve for. So let's do that right now. So, subtract the x to both sides. And divide by -3 so we can figure out what the slope is. 2 negatives make a positive. All right, so line 1 is y equals 1/3 x minus 3. Line 2, line 3, line 4. So let's circle the slopes for each one. So, line 1 is 1/3, line 2 is -2, line 3 is 1/3, and line 4 is -1/2. Well, what has the same slopes? Line 1 and line 3. Your answer is D. All right, folks, so that is day 1, unit 7. Thanks for joining me, and rock out that homework. Get started. Have a good day.